In this video, we will look at another example of modified internal rate of return or MIRR. Consider the following cash flow for a project. Find out the MIRR for the project. The project's cost of capital is 10%. These cash flows are in rupees. Now, the project has a total tenure of 3 years. In the beginning of the project, there is a cash outflow of 100 rupees. At the end of first year, there is a cash inflow of 10 rupees. At the end of second year, there is a cash inflow of 60 rupees. And at the end of third year, there is a cash inflow of 80 rupees. So let me first represent this project on a time scale. So this is the time scale for this project, and K is cost of capital, which is 10%. Now we know that MIRR is the discount rate at which the present value of the cash outflows is equal to the present value of the terminal value of the cash inflows. So let's first find out the terminal value of cash inflows. Now what does this mean? So terminal value of the cash inflows means we have to find out the value of the inflows at the end of the tenure. So this is for the 10 rupees. Let's say this is FV1. This is for the 60 rupees. Let's say this is FV2. And this is for the 80 rupees. Let's say this is FV3. So the terminal value will be the addition of all these three. And this future value will be found at the cost of capital. So TV or terminal value is equal to FV1 plus FV2 plus FV3. Now we know the future value is nothing but present value into 1 plus K to the power N1 plus PV2 into 1 plus K to the power N2 plus PV3 into 1 plus K to the power N3. So this is equal to, now for PV1 the value is 10 into 1 plus K. Now K is 10%. When we use in this formula, we'll have to divide 10 by 100. So this becomes 0.1. So 1 plus 0.1 becomes 1.1 to the power N1. Now this 10 rupees will be compounded for the next 2 years. So this is 2 plus PV2 is 60 into bracket 1.1. 60 will be compounded for 1 year. So this will be 1 plus PV3 is 80 into 1.1. Now N3 is 0 because 80 is not going to be compounded for any duration. So this is equal to 158.1 rupees. So the terminal value is equal to 158.1 rupees. So here we know the present value of cash outflows. There is only one cash outflow and its value is at the present value. We know the terminal value of the cash inflows, which is 158.1. Now this terminal value has to be brought to its present value. And this present value of cash outflows will be equal to the present value of this terminal value of cash inflows at the MIRR. Or in other words, the rate at which the present value of cash outflows is equal to the present value of the terminal value of cash inflows is the MIRR. So let's equate these two. So basically the present value of cash outflows is 100. So 100 is equal to the present value of the terminal value. Now we know that present value is equal to future value divided by 1 plus I to the power n. Here the future value is the terminal value, which is 158.1 divided by 1 plus I. Here I is the modified internal rate of return, which will be represented as R. So 1 plus R, and the total tenure for which this is being discounted is 1, 2 and 3. So 3 years. So or let's take this 1 plus R to the power 3 on one side. 1 plus R cube is equal to 158.1 divided by 100, or 1 plus R cube is equal to 1.581. So we can take the cube root on both the sides. So or 1 plus R is equal to 1.165, or R is equal to, so we'll take this 1 on the other side. So this becomes 0.165. So basically the modified internal rate of return is equal to 16.5%.